Hi, this is Mr. Miller, and welcome to this video. We're going to do a few examples of solving rational inequalities. All right, here we go. The first way we're going to solve rational inequalities is by using a graph. So here we have a graph of a rational function, and we are looking for the values of x where f of x is less than 0. Okay, well, we got to identify the portions of the graph that are below the x-axis. So we see that this piece here down here is below the x-axis. So we have values of x that go up to this x-intercept. All right, so that would be from minus infinity to 2, and not including 2 because that's where it's 0. And this piece, this whole piece right here is below the x-axis. And it starts at the vertical asymptote, which is at 4 here, and goes on to infinity. All right, so we're going to say union 4 and curve parentheses, because it's not including where the vertical asymptote is, to infinity. Okay. So using a graph, it's not that bad. It's very much like what we've done in the past. Right? Here's another example. This time it's less than or equal to 0. Okay, so here's our graph. And we want where it's below the x-axis. This is the x-axis right here. And the part where it's below is just this piece right here. From here, this x-intercept to the asymptote, which occurs at 2. So it's actually 0 at negative 4, and we're going to include that, so we're going to have a square bracket, and we're going to go up to 2, but not include it because that's where a vertical asymptote is. So those are the values of x where the graph is less than or equal to 0. All right, we can do this without a graph also. We're going to create what's called a sign graph. And in order to create a sign graph, we're going to mark the locations on the x-axis where the zeros lie and where the vertical asymptotes lie. These are the points where the function can change signs from positive to negative or from negative to positive. So first I'm going to locate where the zeros are. So that happens when the numerator is equal to 0. So if I solve this, I get 3x equals 12 or x equals 4. That's the x-intercept. So I'm going to mark that. Here's x equals 4. I'm also going to mark the location where the vertical asymptote is. And in this case, that happens when the denominator is 0 or when x is equal to negative 7. So the vertical asymptote here and the 0 divide the number line up into 3 intervals. And we're just going to check them. Is the function positive or negative on those 3 intervals? So I'm going to pick a test point in each interval and just put it into the function and see if it's positive or negative. So I'm going to put in negative 10. When I put in x equals negative 10 in the numerator, we're going to have negative 30 minus 12, which would be negative 42. And in the denominator, negative 10 plus 7 is negative 3. A negative divided by a negative is a positive. So just by picking a value of x in this interval and putting it into the function, you can see whether the whole thing is positive or negative there. All right, a good number to put in between negative 7 and 4 is 0. So when I put 0 into the function, in the numerator, we have 3 times 0, which is 0, minus 12. So we have negative 12. In the denominator, 0 plus 7 is 7. Negative 12 over 7 is a negative number. And finally, I'm going to put in a number greater than 4. How about positive 10? When I put in positive 10 into the function, let's see what we get. So this would be 3 times 10 is 30, minus 12 is 18. 10 plus 7 is 17. A positive divided by positive is a positive. So now I know where the function is positive and negative. We can write the answer. We want to know where it was greater than 0. So is greater than 0 from negative infinity to negative 7, and from 4 to infinity. Okay, we did it without decimals. All right, one more example like this. We're going to create a sign graph for this. So same thing, we're going to mark the location of the 0 and the x-intercept. So here, the 0 would be where x equals 9. It's kind of in fracted form. So if I put a 9, 9 minus 9 is 0. So we're going to put a point at x equals 9. And the vertical asymptote is going to happen when x equals 6. So that's to the left here. Okay. And there are my 3 intervals. So again, we're going to put in test points. A good point to put in that's less than 6 is 0. So if I put in 0, 2 times 0 minus 9 over 0 minus 6, well, that's negative 18 over negative 6, which is positive. All right. If I put in a number between 6 and 9, say 7, we'd have 2 times 7 minus 9 over 7 minus 6. Well, that's negative 4 over 1, which is negative. If I put in a number greater than 9, say 10, I have 2 times 10 minus 9 over 10 minus 6, which is 2 over 4, which is positive. Okay, so we want to know where it was greater than or equal to 0. Right here I got to be a little bit careful. This is where the vertical asymptote is and the function's undefined. This is an x-intercept here. So we want where it's greater than or equal to 0. So it's going to go from negative infinity to 6. Not including 6, because that's where the vertical asymptote is. Union 9 to infinity. And square bracket, because this is where the x-intercept is, and we actually wanted where it was equal to 0. So there we go. There's the solution to our inequality. Again, we use a sign graph and not decimals, so that's doing pretty good. All right, good luck on everything.